Hi, welcome back to Moose in Chemistry. This is Lewis structure lesson number 3. Okay, remember that Lewis structures represent the number of valence electrons around each atom in a compound structure, and they tried to show how these structures share these valence electrons. Okay, let's look at the compound SHF. Right, the first element is sulfur. It's in group 16, so I'm going to cross out that 1, and that tells me that I can put 6 valence electrons around the sulfur, just like this. Okay, pretty darn snarly. Hydrogen only has 1, so there's 1 there. Cross out the 1 there, that tells me I got 7 valence electrons. All right, it's also important to remember that 2 dots right here equals a dash when you're doing Lewis structures. All right, so let's figure out how many valence electrons we have for this particular compound. So we have 1s, so we go S is 1 times 6 electrons. H is 1 times 1 electron. And F is 1 times 7 electrons. So let's add all of this up right now. So this gives me 6 electrons. This gives me 1 electron. This gives me 7 electrons. That adds up to be 14 valence electrons. So whatever structure I draw has to have 14 valence electrons. So the next thing is we have to determine which one's the core. We got 3 of these guys here, so which one's going to be our core? It's the one with the most docking groups, and that's going to be sulfur. All right, so now we're going to put sulfur in the middle. And since we know that we have 2 dots here and 2 dots here, we're going to branch out the F in this direction. And we're going to branch out the H in that direction. Okay, so let's take this a little bit further now. So let's see if this is the best possible structure. But first, wait a minute. We have to count up all our electrons. So we got to give fluorine its octet. What about hydrogen? Does hydrogen get an octet? No. Hydrogen doesn't have an octet. So let's count our electrons. 2, 4, 6, 8, 10, 12, 14. All right, now we got to determine if this is the best possible structure. To do that, we're going to use something called formal charge. Formal charge equals valence electrons minus non-bonding electrons minus bonding electron pair. Okay, let's go and do this. All right, so let's do the formal charge for each of these. Formal charge for sulfur first. Sulfur brings 6 valence electrons to the compound. Non-bonding electrons, there are 4 of them. Right? There's 2 here and 2 here. Okay? Now, and then bonding pairs, we have 1 here and we have 1 there. So that gives me 2. Okay. So 6 minus 4 minus 2 is 0. So that works out well. Let's look at the formal charge for H next, okay? H comes in with 1 valence electron. Non-bonding electrons, nope, they're all used up. And like I showed you earlier, that this H has 1 bonding pair. So that gives me also a 0. This is looking really, really good. Let's do the formal charge for fluorine next. All right, fluorine has 7 valence electrons coming in. It has 6 non-bonding electrons. Watch. 2 and 2 and 2 make 6, right? So, and then we have 1 bonding pair, which we have right there. So that also equals 0. So this is the best possible structure for SHF. Well, listen, you guys, you be snarly. I will see you back here at Moose in Chemistry.